All right, guys, so we're going to be starting our next section today, which is section 3.4. We're going to be talking about angles of right triangles. And we're going to talk about kind of one special relationship that exists between the acute angles of a right triangle. And then we'll just do a little bit of a review to make sure everything from before break also makes sense. Okay, so as a warm-up, let's give each of the trig ratios as a fraction for this triangle that we've got ABC. You've got sides of 10, 24, and 26. Let's start with our angle A. We're going to find both the sine and cosine of A. Now, for angle A, remember that the side for 10 would be the opposite side, 24 would be the adjacent side, and 26 would be our hypotenuse. Okay, so remember, also we're going to be using SOHCAHTOA to find those ratios. Let's start with sine. So sine, remember, is your opposite side divided by your hypotenuse. So opposite side is 10 divided by your hypotenuse is 26. And then we can simplify that. 10 and 26 are both divisible by 2. So that would become 5 over 13. Next, let's find cosine of A. Remember, cosine is adjacent divided by hypotenuse. So we're going to take our adjacent side, which is 24, divided by our hypotenuse, which is 26. And then once again, we'll go ahead and simplify. Both are divisible by 2. So that becomes 12 over 13 when we simplify. Okay, next let's go do the same thing for angle B. So I'm going to get rid of all of that stuff. We'll go ahead and find angle B. So for angle B, we're going to have a little bit different sides. 24 now is going to be our opposite side. 10 is going to be our adjacent side. And 26 is still going to be our hypotenuse. All right, so for sine of B, once again, we're taking opposite divided by hypotenuse. So that is 24 divided by 26. And once again, that's going to simplify. We've actually already simplified that. So we can just take a look at what we did actually for cosine of A, and that is 12 over 13. Next, let's go ahead and find cosine of B. Remember, once again, cosine is adjacent divided by hypotenuse. So that would be 10 over 26. And once again, we'll simplify that. It becomes 5 over 13. Okay, so now let's talk about some things to notice. What do we notice about the sine of A and cosine of B? So when we compare these two fractions, notice that they are the same. So they are equal. And then what do we notice about cosine of A and sine of B? So comparing these two fractions, well, once again, they are equal. So this is going to give us a special relationship that we're going to talk about. So this is the relationship for the acute angles of a right triangle. So when the sine of A equals the cosine of B, we know that the two angles are going to be complementary. Just a reminder of what that means. Remember, complementary means that if you take the measure of angle A plus the measure of angle B, those have to add to be 90 degrees. Okay, so if we want to solve then, so we've got some equations here, then what we need to remember is that our two angles have to add up to be 90. So if we're given that sine of 42 equals cosine of, and we want to fill in the blank, remember that whatever angle we put in that blank means that it needs to add with 42 to be 90. In other words, let's just call this angle x for right now. If we take 42 plus the measure of angle x, that has to add up to be 90 degrees. So to solve that equation, all we would have to do is subtract by 42 on both sides. And that'll leave us x by itself is equal to, if we take 90 minus 42, that's going to be 48 degrees. And if you wanted to check yourself, what does 42 plus 48 equal? And that is actually 90. Now, an even easier way to think about this, that you don't have to use a variable, is really if you just take 90 minus the angle you're given. So on the next one, 90 minus 37, that should give us our missing angle. So 90 minus 37 is 53. So So our missing angle up here would be 53 degrees. And then we'll do the same thing on this last one, so 63.9. So if we take 90 minus 63.9, we get 26.1, and there would be our missing angle. All right, let's do a few more practices with this. This time, we're going to have a few more variables in there to solve for. So we've got our sine of x minus 5 is equal to cosine of 35. And remember that those two angles, so x minus 5 and 35, have to add. So if we add them together, x plus 5 plus 35, remember that those have to add up to be 90 degrees. All right, so now let's go ahead and try and solve for x. We'll combine our like terms. So if we take a minus 5 plus 35, that's going to be a positive 30, so x plus 30 has to equal 90. And then we'll just subtract 30 from each side. And that's going to give us x is equal to 60. Okay, let's do the same thing on the next one. So if we take our two angles and add them together, so 2x minus 7 plus x minus 4, those have to add to be 90 degrees. Okay, let's combine our like terms. So 2x plus 1x, that would add up to be 3x. Negative 7 plus negative 4 would be negative 11, has to add to be 90. Okay, so now let's go ahead and add over the 11. So we're going to have that 3x is equal to 90 plus 11 is 101. And then just divide each side by 3. And we're going to get x is equal to 33.7 to the nearest 10th. Okay, let's do one last practice with this, and then we'll go back and do a little bit of review. So again, remember two angles have to add up to be 90 degrees. So 3 plus 6x plus 4x plus 7 has to add to be 90. Okay, so let's go ahead and combine our like terms. 6x plus 4x is 10x. 3 plus 7 is 10 is equal to 90. So then we'll go ahead and start solving for x. So subtract 10 from each side. And we'll get that 10x is equal to 80. And then divide each side by 10. And we'll get that x is equal to 8. Okay, so let's go back and do a little review to make sure everything still makes sense, and then we will call it a day. So if you are trying to find a missing side of a triangle, you're going to want to use the regular trig ratios. However, if you're wanting to find a missing angle of a triangle, you're going to want to use the inverse trig ratios. So remember that there's a difference between finding a missing side and finding a missing angle. Also, don't forget your ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, SOHCAHTOA is the easy way to remember those. Okay, so let's use that trigonometry to solve for some variables here. We've just got a few problems to practice to review what we've looked at so far. Let's go ahead and take a look. So on our first triangle, we've got our angle of 39. We've got 11, which is our opposite side, and x, which is our adjacent side. So opposite and adjacent tells us to use tangent. So we're going to take the tangent of our angle of 39 is equal to opposite 11 over adjacent, which is x. And then once you've got your equation set up, it's just a matter of how are we going to solve. Well, to get x by itself, right now x is in the denominator for our fraction. Remember that this is where you can swap it with the other side of your equation and say that x is equal to 11 divided by the tangent of 39. Now all that's left is to get that typed in for a decimal approximation. For sides, we're rounding to the nearest tenth. Okay, so if we take 11, divided by our tangent of 39, that's going to be 13.6 to the nearest tenth. Okay, let's take a look at the next fraction and see how it's a little bit different. So we've got our angle still, which is x. We have 25, which is opposite, 78, which is adjacent. So we still have opposite and adjacent, so we're still using tangent. So we'll say that the tangent of x is equal to our opposite side, which is 25, divided by our adjacent side, which is 78. Okay, so now, because x is an angle, and we need to solve for it, remember, when you're looking for an angle, you're using inverse trig function. So our next step would be to change our tangent to tangent inverse, so tangent -1, of our fraction, which is 25 over 78, and that's going to be equal to our variable now, which is x. So now all that's left is to put that in our calculator. So let's go ahead and do that now. So remember, tangent inverse, you're hitting the functions button, and tangent to the -1, typing in our fraction, so 25 over 78, and that is equal to, and remember for angles, we just want the nearest degree, so the nearest whole number, so we'll round that up to 18. All right, let's take a look at a few more examples. So on our next example, we've got our angle x, we've got our side which is opposite that angle, and 19 would be our side which is our hypotenuse. So opposite and hypotenuse, O and H tell us to use sine, so we would take the sine of our angle x is equal to opposite, which is 10, divided by hypotenuse, which is 19. Once again, since x is inside of sine, we're going to use our inverse trig ratios to solve here. So we're going to take sine inverse of our fraction, which is 10 over 19, and that needs to be equal to x. All right, so we should be ready to go ahead and type that in now. So again, we'll go to our functions, sine inverse, take 10 divided by 19, and that's going to be to the nearest whole number, nearest degree. We'll round that up to 32. All right, let's take a look at another one. So we've got our angle, which is 46 degrees on this next triangle. We've got our side, which is adjacent to that. We also have our hypotenuse. Okay, so adjacent and hypotenuse tell us to use cosine. So the cosine of our angle, which is 46, is equal to our adjacent side, which is x, divided by our hypotenuse, which is 28. So this time our variable is not inside of cosine, so we don't need to use inverse functions. Also, our variable is not in the denominator, so we're not going to swap it with the other side of our equation. Instead, we're going to multiply it by whatever the denominator of our fraction is. So we're going to multiply by 28 on both sides of our equation. So that means that 28 multiplied by the cosine of 46 is equal to x. So now we'll just type that in to get our approximation. So 28 cosine of 46, and that's equal to, and this time we're rounding to the nearest tenth since it's a side, that's going to be 19.5 when we round up. All right, just two more problems to look at, and then we'll be done with this section. So in the next problem, we've got our angle, which is 24. We've got our side opposite the angle, which is x, and we've got our hypotenuse, which is 31. Okay, so opposite and hypotenuse, that's our clue to use sine. So we'll take the sine of our angle 24, has to equal our opposite side, which is x, divided by our hypotenuse, which is 31. And then to solve this, just like we did on the last triangle actually, our variable is in the numerator, so we'll multiply by the number in our denominator, so multiply by 31 on each side. So that's going to leave us with 31 multiplied by the sine of 24 being equal to x. Now let's type that in and get our decimal. So 31 sine of 24 to the nearest tenth is going to be 12.6. All right, one last problem to look at, and we'll be done with this section. So on our last problem, we've got our angle, which is x. We've got our side, which is adjacent to that, which is 31. And we've got our hypotenuse, which is 36. So adjacent and hypotenuse is our clue to use cosine. So cosine of x is equal to our adjacent side, which is 31, over our hypotenuse, which is 36. Okay, so this time, since x is inside cosine, that's our clue to use inverse trig functions. So we'll take cosine inverse of our fraction, which is 31 over 36, and that has to equal x. So now let's type that into our calculator. We'll do cosine inverse 31 over 36. And remember, for our angles, we're going to the nearest whole degree, so we'll round that up to being 31 degrees. All right, guys, that's all we've got for this time. Until next time, have a great rest of your day.